All right, part C, very similar, just a different number. We're going to subtract 45 on both sides. We get x squared equals negative 45. Then we're going to square root both sides. So we get x equals positive square root of negative 45. And x is the negative square root of negative 45. Now this is another example of one where we can reduce this and get a perfect square. So I'm going to switch this to 9 times 5 times negative 1 because this is a perfect square. I can take the square root of 9 and it will be a pretty number. That's why I changed 45 into 9 times 5. So they'll each get their own radical. We get 3 for this one. This one gives us an I, and then root 5. Then over here, same idea. So we've got, you could skip all of this and skip to the end and just make it negative, but I'll work it out for you. So we've got x equals the square root, negative square root, 9 times 5 times negative 1. So we get negative square root of 9, square root of 5, square root of negative 1. So we get negative 3, this part is an I, square root 5. So that's what I meant, like you can skip all this and just really just put a negative out front. Okay, last one. To solve for x, let's subtract 5 on both sides. We have x minus 2 squared equals negative 5. We're going to square root both sides. And we'll end up with x minus 2 equals the square root of negative 5. And x minus 2 equals the negative square root of negative 5. So I'll deal with this one first. This piece becomes I root 5. And then we need to add 2 to both sides. So we've got x equals 2 plus I root 5. And this is important that the number comes first because remember, in a complex number, the real piece comes first. Then over here, we get x minus 2 equals negative I root 5. And we need to add 2 to both sides. So we get x equals 2 minus I root 5. So again, these are complex numbers, complex solutions, and just make sure the real number comes first and the I component comes second. All right, last little section here. Use the quadratic formula to solve for x. So please don't confuse tedium and like time-consuming factor for difficulty. It's really a plug and chug. So if you've forgotten what the quadratic formula is, it's x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So if we look at the first one, part A is 1, b is 3, c is 5. So we're going to plug that in. X equals, opposite b plus or minus the square root of b squared minus 4ac all over 2a. Now, I'm going to put this into the calculator and we'll see what we come up with. 3 squared minus 4 times 1 times 5. Negative 11. All right, so we're going to break this into our two solutions. I'm going to do 2 steps at once. I'm going to make it into imaginary and split them. So we're going to get x equals negative 3 plus I root 11 over 2. That negative I pulled out to an I. And then here we have x equals negative 3 minus I root 11 over 2. Okay, the next one. A is 3, B is negative 3, and C is 2. So we'll plug in our formula. X is equal to opposite B plus or minus the square root of B squared minus 4AC all over 2A. I'm going to type in the square root and see what that's worth. So we've got negative 3 squared minus 4 times 3 times 2. is negative 15. Okay, so this is another imaginary number. I'm going to split this. We're going to get x equals 3 plus I root 15 over 6. And then x equals 3 minus I root 15 over 6. The last thing I had us do in class was to simplify a little bit. My teacher in school told me if it's a heart, break it apart. So if you can draw a heart like this, that means you can do 3 divided by 6 and this divided by 6. You can do them separately. That's convenient because 3 divided by 6 is 1/2. And then this just kind of is stuck as is. You can't really reduce that piece. Then here we get, again, you can do the same exact thing, just change that sign. So x equals 1/2 minus I root 15 over 6. All right, part C. Whoa. A is 1, B is negative 10, C is 34. So go ahead and plug that in. You guys can work ahead. Don't wait for me to write it out. Opposite 10 plus or minus the square root, b squared minus 4ac all over 2a. Ten squared is 100, minus 4 times 34 is like 126, I think, but we'll go 10 negative 36. So this looks ugly, but this one's actually kind of nice because 36 is a perfect square. So we can break this one into x equals 10 plus 6i over 2 and x equals 10 minus 6i over 2. And then again, we have another heart, so we can break it apart. She also said if it's a but, don't touch it. So if it's like this, if it was like this and it's a but, don't touch it. But if it's a heart, break it apart. So we've got 5 plus 3i, and over here, 5 minus 3i. All right, last one, folks. So for this, A, B, and C are 2, negative 4, and 5. X is equal to opposite B plus or minus the square root of B squared minus 4AC all over 2A. So 4 squared minus 4 times 2 times 5. Negative 24 over 4. So this one we have to do a little bit of reducing of the square root of 24. That's going to be 4 times 6 times negative 1. So that's going to become 2i root 6. So I'm going to rewrite this as x equals 4 plus or minus 2i root 6 over 4. It's a heart, break it apart. So we've got x equals 4 divided by 4 is 1. 2 divided by 4 is 1/2. So plus I root 6 over 2. You could put a 1 there if you wanted to, but I won't. And then x equals 1 minus I root 6 over 2. So you really just have to reduce once and then change the sign in the middle. Okay, you guys have worksheet 7.5.1 to work on it. You guys should be able to do the whole thing. If you need to, go ahead, rewind this, rewatch it, pause it, ask me questions, do what you got to do.